Alright, so graphs of sine and cosine. Now, the only difference with these graphs compared to the graphs before is it's periodic. What that means is it repeats itself. So let's just jump right into having a look at what they look like. Now, a normal sine and a normal cos graph I've drawn on the board. Just a sine and a cos. If you've never seen them before, they just look like waves because the wave equation is made up of sine and cos normally. Then this is one period of it, as in it's one repetition of it. Now, general equations, you always have a dilation factor in the front. So this first one here is the dilation. Oh gee, that's thick. And then n is related to your period. So your, why can't I scroll to red? This makes no sense. That one. N tells you what the period is. Your period is 2 pi over n. Then the green one, you should know what that one is. What's h normally? X, yes, the change in x. So in other words, horizontal translation. And k, y, so vertical translation. So cos is the same. You might notice that it just starts from the peak of the wave instead of the middle bit. That's the only difference. So what people quite often say is cos is a shifted version of sine. You'll learn that a little bit later, so I'll just write in all the stuff. What's A again? Dilation. N tells you the period. Whoa. This is so hard to tap. Okay. N is the period. 2 pi over n. The h is a horizontal translation again. And k is vertical translation. Any questions with that? Now, generally you just have to solve for the points on where they cross over the x-axis, as well as the height. So to find the height of a wave, and if you're doing physics you might find this quite interesting, you find the amplitude. The amplitude is actually equivalent to your dilation. In other words, whatever's in the front tells you what the amplitude is. If it's a 1, then it will go between -1 and 1. So in this case, it will go in between -1 and 1. If you have 2, then it will go between -2 and 2. 3, -3 and 3. Fairly straightforward. Then you just have to add the shift of the vertical shift, and then you have your full graph. Alright, sketch a graph of y equals the sine of x over the domain -2 pi to 4 pi, and then state the number of cycles. So, what's our n in this case? What's the number in front of this? 1. So our period is 2 pi over 1, which is equal to 2 pi. So that means this repeats itself every 2 pi. So if we start off here, we'll do the first one. We have 1 pi. We have 1 cycle, which is up to 2 pi. So if we're going up to 4 pi, how many cycles do I draw? 1 more. Good. Now, sine graphs are symmetrical, same with cos graphs. Actually, in fact, all the graphs are symmetrical. So you should know that between 0 to 2 pi, the one that crosses over is going to be halfway, so it's going to be pi. Alright, this says to go to negative 2 pi though, so how many do I need to draw going backwards, given that one period is 2 pi? 1. Now, you might notice that the way I've drawn it looks kind of ugly. There is a way to solve that problem. You grab a ruler, you line it up first with a dotted line like this. I know dotted line normally means asymptotes, but in this case we're just going to use it so that it crosses the line, so that we have it going straight. And you might notice when I draw it, it looks much nicer. Okay? Any questions? Alright, now, we now have different periods and stuff coming into play. That's fine. That's not the heart bit anyway. The heart bit is when it has vertical shifts, which most of you wouldn't have seen before. Alright. What's our amplitude? 2. So it normally goes from negative 2 to 2, but see how we have a vertical shift of negative 1? You're going to then work out negative 2, and then you're going to shift each one down by 1. Then the other one, what I put in? Good. So what do we get as our range? And 1. Alright. Might need to make this smaller. Oh good, it's 0 to 2 pi. Alright, so negative 3 and 1. Same thing as before, grab a ruler. I'm actually going to use a ruler this time, and you might notice a difference in my beautiful graphing skills. Okay. Then, there's no vertical shift, horizontal shift. So we can figure out our period again. What's our, once we figure out our period, we can draw it. So what's our period? Which is 2 pi. So this says going up to 2 pi. How many cycles am I drawing? 1. Nice and simple. So remember, cos starts from the top, goes to the bottom, then goes back up. And you have to actually label the ending point, which is at 2 pi. Now, you do have to solve for the x-intercepts. So y equals 0 when you have 2 cos x minus 1. Rearranging this, we get cos of x equals to a half. $60. Anyone else? Anyone else? Pi over 3. What's the other one? Very good. 2 pi minus pi over 3. So you have 5 pi over 3. So then these are x values. There, that is not a 3. That is a squiggly line. Okay. So this is working out of A. Sorry, this is going to look a little bit messy. Okay. Now we have a slightly more complicated one. You have 4 minus 2 sine of 3x. So same thing, let's work out our range. we have negative 4 minus 2, sorry, wrong way around. You have negative 2 minus 4, which gives you negative 6. No, it doesn't, it's a plus 4. What am I doing? Sorry, that's a plus, in case you're confused. So you have negative 2 plus 4, which is 2. Sorry, my fault. Then you have 2 plus 4, which is a 6. Now, do our usual thing, draw the range in first. There's one good thing about this one. What do you think I'm going to say? Once you have a look at what the graph is in between. There's something that you can just completely ignore. Well, there's something that you don't have to work out, which makes it nice and simple. Yep, the x-intercepts. But we have to work out our ending points. Okay. So let's work out our starting point first. Actually, work out our period first. We have 2 pi over 3. That means each cycle is worth 2 pi over 3. And remember, sine normally starts in the middle, which is at 4 for this case. And this one is a negative sign. Then we also have to work out our starting point, which is at negative pi over 2. Someone want to help me with that? It's a pi over 2, so sine going to be 1 or 0. Pi over 2, sine of pi over 2, anyone? 1 or 0? 1, because sine's a y value, right? Then 3 pi over 2 makes it negative 1, but there's a negative of it. That means you're technically going backwards that way to here. So is that 1 or negative 1? 1. 4 minus 2, which is a 2. So we're starting off here. I should probably extend this a little. Alright, we're starting off here at negative pi over 2. Then we're stopping at 3 pi over 2. What's that? If it helps, that's the same as 4 pi plus pi over 2. If it goes through 4 pi, what happens? It goes back to the start, right? So that means we have sine of pi on 2, so that's 4 minus 2 again, because that's a 1, so then you get a 2. Quickly, quickly, take a seat. Alright. So we're going up. We have 2 pi over 3. This goes for this domain here goes for 2 pi. So 2 pi divided by 2 pi over 3 gives us how many cycles? If you don't know how to work that out, write it out step by step. 2 pi divided by 2 pi over 3 means you keep the first one, you change a second thing, which is a divide to a times, and you flip it, so you get a 3. So then we just draw 3 cycles, so that's 1, 2, hang on, 3, okay? It is a little bit annoying, but you might notice that once you work it out, you just have to know how many cycles you have. Each period is 2 pi over 3, so then if you know the full range of this, you just divide it and work out how many cycles you need to draw in, okay? If you're not quite sure, it's alright, just have a look at it a little bit later. You'll kind of get it. Alright, I'll just quickly finish this off if my computer stops spazzing out. Alright, sketch a graph of that from 0 to 2 pi. Now, this time we have a shift by pi on 4. So, is that shifted forwards or backwards? Forwards. So now that's a normal shape. If we shift it forwards that way, what does our shape become? By pi on 4. Remember that's pi on 2. Oh, sorry, that's pi. That's pi on 2. So if we shift it forwards by that little bit, you end up getting something slightly curved here to there. So it kind of look like a sine graph. I can't do this properly. There. Oh my god. It kind of look like that, okay, because we shifted it forwards. Now, remember we can solve this using the implied domain. Do you want me to write the rest of the stuff out first so you can see what it is? Okay. Let's start with amplitude. What's our amplitude? The number in the front. It doesn't matter, it's always just a number in the front. Just make it positive. What's our period? What's our number in front of x? 1, so that's 2 pi over 1, so that's a 2 pi. Now, we then have to work out the shift. Doesn't matter, you just simply work out the different parts and then you should be able to get it. So, what I'll do is I'll work out the x-intercepts first, and then we'll work out the starting point, then you should be able to draw the rest. Alright, x-intercepts, how do we do this again? Yes, but what do we need to do first? Anyone remember? We have to change our domain first, remember that? We need to find out our implied domain. So it says it's shifted by minus pi over 4, so we'll just minus pi over 4 here for each one. And 2 pi minus pi over 4 is? Yep. Alright. You divide both sides by root 2, you get the same answer. So it's 0. When is cos equal to 0? 0 is one of them. What's the other one? Actually, it's not 0. What am I on about? Yes, it's 90. So it's pi over 2. And what else? Are there any others? No? Sounds good. Alright, then just add each one by pi over 4. So we get 2 pi over 4 plus pi over 4 gives you 3 pi over 4. 3 pi over 2. Oh, maybe I should write that out so you can see what I'm doing. Pi over 2 plus pi over 4 3 pi over 2 plus pi over 4. 3 pi over 4. What's that? 6, 7, 7 pi over 4. I'm presuming I did that right. Okay. Then, I'm running out of space. We need the starting point as well. Then we can draw it. So our starting point, we have x equals to 0, so y equals to root 2. X does not equal to 0. X is equal to 0. Alright, what's cos of negative pi over 4? Which is the same as cos of pi over 4, if you remember what I showed you last time. 1 over root 2, so then root 2 times 1 over root 2 gives you 1. Alright. So, starts at 1. Then, we said before it looks like this. So it goes up a little, comes back down, and it will stop at 1. What's its final value? 2 pi, and we've already worked out the x-intercepts. Okay. I'll do part B in 1 second. Okay, so this really needs to stop doing that. Part B. State the period and amplitude range and phase shift for the graph of y equals to that. Now, to do this, we need to rearrange it a little. Just a little, not very much. What's the only thing that we can't really find yet? Hence, it's not the period.
The range?
Nope. It's actually the horizontal shift. If you saw what I showed you on the board just before, you need it in this form. A f of n x minus h plus k. Notice that that's factorized. Once you factorize it, then you can write everything out. If you get a little bit annoyed with the brackets, you are allowed to do this. I'm just going to do this once. It's up to you if you want to do it. So once you factorize it, then you can write your stuff out. Period. 2 pi over 4. So what's that? Yep, pi over 2. What do we need? Amplitude. What's our amplitude? Amplitude's always positive. This really needs to stop for free. I know the battery's low, thank you. Range. Remember it's with the shift, so we have negative 2 plus 5, 2 plus 5, giving us a 3 and a 7. And then phase shift. Alright, phase shift, that's a plus, so change it to a minus. Alright. So, general form. K f of n x minus h plus k. Alright. So, if we look at this in terms of cos, there's no shift. So, by cosine, if you have a look at added in terms of cosine, there's no shift horizontally, so we can try working out y equals to a f of nx plus k. Now, the other version of this is by working out as a sine. If there is a sine graph, remember sine starts from 0, so that's a 0. From here to here, there's our shift. So then by sine, we would have a f of n x. Now this is shifted forward, and you can see that's by pi. So that's n of x minus pi plus k. So then the only thing we have to work out is n, a, and k. Now, they're going to be different depending on which one we're working out. You'll see why in 1 second. So by cosine, our a, this is a flipped over version of sine, so that's negative. So we have -4 as the amplitude, because that's our height. Our n is our period. If you look on the period here from the start to the finish, that's 4 pi. Well, it's also equal to 2 pi over n. Oops, made a mistake. That should be p. So then n is equal to 2 pi over 4 pi, which is a half. And then our k, if you have a look, the center is at 0, so our k is 0. So therefore, y is equal to -4 cos of a half x. So then by sine, now if you have a look, sine is just shifted to the side, so it starts off at 0 there and it goes upwards. So it's not negative, so it's just a 4. Here it's going to be the same, it's going to be a half. Then k is also 0, so then following the form from before, with y equals to 4 sine